Okay, so this is going to be the second video in the series that deals with practice problems for molarity, and you should have already gone through the previous videos so you can understand what molarity is about, what moles are about, and through the first video of practice problems if that didn't go too slow for you. This second video, we're going to pick up the pace a little bit, and we're going to change some of the questions around. So the questions are all going to be worded in different ways. And so you might need to find the molarity, you might need to find the moles, you might need to find the grams, you might need to find the liters. So we're really going to pick up the pace here and give you some further textbook examples of what you might be asked on an assignment or a test. So what volume of each solution, so that's each of these solutions, 1, 2, 3, what volume of each solution contains 0.15 moles of KCl? And KCl is just potassium chloride. The K stands for potassium and the Cl stands for the chloride. So we need to get 0.15 moles of KCl, of potassium chloride. How much of a volume? So we're dealing with volume. So if they're asking about volume, then you know they're going to be asking about how many liters. How many liters of solution are we going to make, and what is going to be the recipe to make that solution? So what volume of each solution contains 0.15 moles of potassium chloride? Let's look at this first example. We have a molarity of 0.255 potassium chloride. And you know it's molarity because it's got that capital M after it. So this value, this 0.255, is a molarity of potassium chloride. So what does that mean, molarity? Well, as we were talking about in the previous videos, molarity is always some number of moles in 1 liter of water. And so if we have a 0.255 molarity, that means that we have 0.255 moles in 1 liter of water. So if we have 0.255 moles in 1 liter of water, but we need to find out what is the volume, how much water do we add if we only have 0.15 moles of potassium chloride? So how do we do that? We need to turn this 0.255 moles into 0.15 moles of potassium chloride, and that is going to tell us how we can turn this liter of water into however many liters of water we need for this problem. So if we have 0.255 moles over 1 liter, and we need to go to 0.15 moles over so many liters. How do we do that? How do we go from 0.255 moles to 0.15 moles? Well, we can divide. We can divide the 0.255 moles divided by our end result, what we want the result to be, 0.15. And that will give us a divisor that we can use on the 1 liter. So if we divide 0.255 divided by 0.15, That's going to give us 1.7. So, by the rule of division, if we divide 0.255 by 0.15 and we get 1.7, then we can change these around and we can divide 0.255 divided by 1.7 and get 0.15. So that's exactly what we're going to do. We're going to take this 0.255 moles and divide it by 1.7, and that's going to give us our 0.15 moles. Now, what we do on the top, we have to do on the bottom. So we have this 1 liter over here, and we need to divide that 1 liter by 1.7. So if you take your calculator and you go 1 divided by 1.7, that's going to give us 0.5882. So if you have 0.55, if the molarity is 0.255, like it said up in the problem, and we changed that into 0.15 by dividing by 1.7, that 1 liter down there needs to be divided by 1.7 also, and that gives us 0.5882 liters. So this would be the volume of the solution if it contained 0.15 moles of potassium chloride. Now let's look at the next problem. We have 1.8 molarity of potassium chloride. So again, molarity, which is a capital M, equals the number of moles in 1 liter. Always 1 liter for molarity. So if we have a 1.8 molarity, which is right here, then that means we have 1.8 moles of potassium chloride in 1 liter of water. So the question is, up at the very top, what volume of each solution contains 0.15 moles of potassium chloride? So we need to take that 1.8 moles of potassium chloride and turn it into 0.15 moles of potassium chloride, and that's going to give us a specific volume. That's going to give us so many liters. And how many liters is that? We don't know. We have to find out. So how do we find that out? Well, if we need to change 1.8 moles to 0.15 moles, we can divide 1.8 divided by 0.15 moles, which is an even 12. So that means if we take 1.8 and divide it by 12, that's going to give us 0.15. So that's exactly what we're going to do. Let me erase this. We're going to take this 1.8 moles of potassium chloride and we're going to divide it by 12. And that's going to give us 0.15 moles of potassium chloride. And what you do to the top, you have to do to the bottom. So we need to take that 1 liter of water and divide it by 12. So 1 divided by 12 is going to be, let me erase this question mark here. 1 divided by 12 is going to be 0.0833. So 0.833 liters is how much you need to have of a 1.8 molarity of potassium chloride if you only want 0.15 moles in your solution. So your total volume of your solution that you want is 0.0833 liters. Now let's do the third one. We have 0.995 molarity of potassium chloride. Well, you should know by now that molarity means you have 0.995 moles in 1 liter. And we need to change that to 0.15 moles and find out how many liters that is. So if we divide the 0.995 divided by the 0.15, that's going to give us 6.633. So that's what we're going to do. We're going to divide this 0.995 by 6.633, and that's going to give us 0.15 moles. So what we do on the top, we have to do on the bottom. So we're going to divide this 1 liter by 6.633. So 1 divided by 6.633 is 0.1508. So your answer is going to be 0.1508 liters is going to be the amount of this solution that will only contain 0.15 moles of potassium chloride in it. So your answer is 0.1508. So now we're going to complete the table. As you can see, they give us the solute, which is, I always think solute sounds like salt. So it's the salt that you're going to put in the water to make salt water. Or it's the powder Kool-Aid that you're going to put in the liter of water to make Kool-Aid, the Kool-Aid solution. So it's pretty much the powder that you're going to add to the liter of water to make the solution is what the solute is. So I always think solute sounds like salt to me, so it makes me think of salt. So the first solute is potassium nitrate, that's KNO3, and its solute mass is 22.5. The moles of the solute, we have to find out how many moles are 22.5 grams. So if you look at this KNO3, don't pay attention to the bottom 2 rows because we haven't gotten there yet. Just paying attention to the KNO3, the potassium nitrate. It's telling us that we have 22.5 grams of potassium nitrate. So how many moles is that? How many moles is 22.5 grams of potassium nitrate? Well, we know that potassium nitrate is KNO3. That means 1 mole of potassium, 1 mole of nitrogen, and 3 moles of oxygen. Because remember, the little 3 down here as a subscript only applies to the element it is directly following. So that 3 only applies to the O, the oxygen. The other 2, the K and the N, they each just get or have 1 mole. So let's go to the periodic table and see how many grams are in a mole of potassium nitrate. Okay, so here's potassium over here on the left, and its atomic weight is 39.1. So 39.10 grams equals 1 mole of potassium. And then we have a total of potassium nitrate. So now we did the K, now we need to do the N, the nitrogen. And nitrogen is over here, and its molecular or atomic weight is 14.01. So 14.01 grams is 1 mole of nitrogen. And now we have 3 moles of oxygen. And oxygen is right next to the nitrogen here. Oxygen is 16 grams per mole, 16.00 grams per mole equals 1 mole of oxygen. But we don't have 1 mole of oxygen, we have 3 moles of oxygen. So we need to take that 16 times 3. So 16 times 3 is 48. So that means we have 48 grams in 1 mole of O3. So all we have to do, we need to add up the K and the N and the O3. So we just need to add up the 39.10, the 14.01, and the 48 grams. And 39.10 plus 14.01 plus 48 is 101.11. So that's how many grams are in 1 mole of potassium nitrate. So let's bring this 101.11 grams back to our practice page. Okay, so we have 101.11 grams per mole of potassium nitrate. But what the chart's telling us is that we only have 22.5 grams of potassium nitrate. We don't have a whole mole of potassium nitrate. A whole mole would be the 101.11 grams, but we only have 22.5 grams. So if we take the 22.5 grams that we do have, and I put it over 1, and we multiply 1 mole of potassium nitrate is 101.11 grams, then we end up getting 22.5 divided by 101.11. So 22.5 divided by 101.11 is 0.2225. So we have 0.2225 moles of potassium nitrate. So let me erase this little block and we'll fill this in. We have 0.2225 moles of potassium nitrate. And then it's telling us how much water we put in with the 0.2225 moles. So remember, molarity, capital M, is the number of moles in 1 liter of water. Well, we don't have 1 liter of water. We have, for moles, we have 0.2225 moles, and we only have 125.0 milliliters. Now, do you notice something funny? This is in milliliters. We need to change this to liters. So my shortcut for changing milliliters into liters is you just take the decimal point and you move it back 3 spaces. So that it gives us 0.1250 liters instead of this milliliters business. So now we need to change this 0.2225 moles over 0.1250 liters. We need to find the molarity. So we need to find out how many moles are in 1 liter. And to do that, we need to change this 0.1250 liters into 1 liter. So how do we do that? Well, we divide. Divided by itself, divided by 0.1250 liters, because that gives us 1. And so that's what we're looking for. We're looking for 1 liter. So if we divide the bottom, if we divide this 0.1250 liters by 0.1250 liters to get 1 liter, we have to do that to the top. So we need to divide 0.2225 moles by 0.1250. And that's going to give us, let me erase this question mark, and that's going to give us 1.78 moles. And that's going to give us 1.78 moles out of 1 liter. So if we have 1.78 moles in 1 liter of solution, that means the molarity is 1.78, and then you put a capital M at the end to show that it's molarity. Okay, so on to our next solute. So we have sodium bicarbonate, which is sodium bicarbonate is also known as baking soda. So this is what baking soda looks like in its chemical formula. So we don't know what the mass is. We don't know how many grams of baking soda we have. So we don't know how many moles of baking soda we have. But what we do know is we have 250 milliliters of it, and the molarity is 0.1. So let's start with the molarity first on the very end. The molarity is 0.100 molarity. Well, what is molarity? Molarity is the number of moles in 1 liter of solution. So if we have a 0.100 molarity, that means we have a 0.100 mole in 1 liter of solution, or of 1 liter of water. So now we know how many moles we have in 1 liter of water. But if you go back to the volume solution box, we don't have 1 liter of water. We only have 250 milliliters of water. So first, let's take that 250 milliliters and change it into liters. Take the decimal point and move it back 3 spaces. Now you have 0.2500 liters. So now we have this change converted to liters. And we know that if we had an entire liter, then we would have 0.1 moles in 1 entire liter. But we don't have an entire liter. We only have 0.25 liters. So, how do we figure out how many moles that is? If you look at how we're going to make the liters into 0.25 liters, if you divide the 1 liter by 0.25, you're going to get 4. So that means if you divide the 1 liter by 4, you'll get 0.25. It can go back and forth like that. So in order to turn this liter into 0.25 liters, we're going to divide it by 4. And what we do on the bottom, we need to do on the top. So we're going to divide this 0.100 moles by 4. So if you divide 0.100 moles by 4, what are you going to get? You're going to get 0.025. So that's 0.025 moles of sodium bicarbonate, or baking soda. So the number of moles of the solute that you have is 0.025. So let's write that in the box. Let's erase this question mark, and we'll write 0.025 moles. So now we need to find out what the masses. How many grams do we have? Well, in order to find out how many grams we have in 0.025 moles, we need to find out how many grams of sodium bicarbonate is in 1 mole of sodium bicarbonate. So that's Na, so that's 1 mole of Na, that's 1 mole of hydrogen, 1 mole of carbon, and 3 moles of oxygen. So let's go to the periodic table and find out how much 1 mole of this baking soda weighs. Okay, so here's our baking soda, NaHCO3, and we have 1 mole of Na, which is sodium. So sodium is down here. Its atomic weight is 22.99. So we only need 1 mole of that. And then we have hydrogen. 1 mole of hydrogen is 1.01. So we have 1 mole of that. Carbon is over on the right. Carbon weighs 12.01 grams per mole of carbon. And we only needed 1 mole of carbon and sodium bicarbonate. But now we have 3 oxygens. Now oxygen is over here by carbon, and oxygen weighs 16 grams and 1 mole of 1 oxygen. But we have 3 oxygens, so we have to take that 16 times the 3 oxygens that we have, and that is 48. So now we have 48 0.00 grams. And now we just need to add them all up. So 22.99 plus 1.01 plus 12.01 plus 48 is 84.01 grams. So sodium bicarbonate has 84.01 grams per mole of baking soda. So let's take this 84.01 grams per mole back to our practice sheet. And we'll write it down here, 84.01 grams per mole. We don't have 84.01 grams. And you know how I know that? Because we don't have 1 whole mole. The 84.01 grams equals 1 full mole, but we don't have 1 full mole. If you look to the second box, we have 0.025 moles. So in order to find out how many grams that 0.025 is, we're just going to take this 84.01 grams per mole and multiply it by the 0.025 moles that we do have. So 84.01 grams per mole, and we only have 0.025 moles. That means we only have 2.10025 grams. So that's what I'm going to put in this box. I'm going to erase the question mark, and we have 2.10025 grams. Okay, so last one. We have C12H22O11, and we have 55.38 grams of that. And it tells us we have a molarity of 0.150. So let's start with the molarity first. If we have a molarity, a 0.150 molarity, that means we have 0.150 moles in 1 liter of solution, in 1 liter of water. All right, so now we know how many moles we have in 1 liter of water. That's where our molarity comes in. Now let's take a look on the very left side of the chart. It's telling us we have 55.38 grams of this carbon 12, hydrogen 22, and oxygen 11. So we need to find out how many grams of the C12H22O11, how many grams of that equals 1 mole. So to do that, we need to go back to the periodic table, and we have C12H22O11. So that means, because this little 12 follows the C, that means there are 12 carbons. This little 22 after the H, that means there's 22 hydrogens. And this little 11 after the O means there's 11 oxygens. So let's start with the carbon. Carbon is over here, and it weighs 12.01 grams per mole. But we have 12 of them. So we need 12.01 times 12. So that's going to give us 144.12 grams for carbon. Now hydrogen is over here, and its atomic weight is 1.01, and we have 22 of them. So 1.01 times 22 is 22.22. So 22.22 grams of hydrogen. Now we have oxygen, and oxygen is over to the right by carbon. Its atomic weight is 16, and we have 11 of them. So we're going to take the 16 that it weighs and times it by 11. So 16 times 11 is 176. So 176 grams of oxygen. So now we just add them all up. We have 144.12 plus 22.22 plus 176. And that comes to 342.34 grams in 1 mole of C12H22O11. So let's take this 342.34 grams per mole back to our practice page. So we have 342.34 grams in 1 mole of C12H22O11. But our table says that we only have 55.38 grams. So how many moles is that if 342.34 grams is 1 mole? Well, we take the 55.38 that we do have and put it over 1, and then we use a multiply sign and a fraction bar, and then we write 1 mole, and on the bottom we write how much that mole is, 342.34 grams. And you multiply them together, which gives you 55.38 over 342.34, which is 0.1618. So 0.1618 is how many moles we have when we only have 55.38 grams of C12H22O11. So let's write that in the box. So under moles of solute, we're going to write 0.1618 moles. Okay, so now it's really fun. So now we have to find out the volume of the solution. So if the molarity is 0.150 moles per liter, remember we found that out earlier, but we only have 0.1618 moles. Well, here's 0.150 moles per liter, per 1 liter, and we need to go to 0.1618 moles in how many liters? So in order to do that, we need to find out the divisor between 0.150 moles and 0.1618 moles. So 0.150 moles divided by 0.1618 moles equals 0.9271. So we have 9271 is our divisor, because if you divide 0.150 by 0.1618, we get 0.9271, or if you divide 0.150 by 0.9271, you're going to get 0.1618. So you can go back and forth with that. So since we have 0.150 moles divided by 0.9271 equals 0.1618, what we did to the top there, we got to do to the bottom. So 1 liter divided by 0.9271 equals, get this question mark out of here, equals 1.079. So 1.079 liters is how much you have if you have 1.6, or if you have 0.1618 moles in a 0.150 molarity concentration solution. So I'm going to write this liter down, 1.079 liters. But look, they have these in milliliters, so maybe we should change it back to milliliters. So in order to change liters back to milliliters, you find the decimal point and you just move it over 3 places. So that gives us 1,079 milliliters. And the chart's done. Now, a chemist wants to make 2.5 liters of a 0.100 molarity of potassium chloride solution. So here's your molarity. How many grams of potassium chloride should the chemist use? Well, let's not worry. He or she wants to make a total of 2.5 liters. But we shouldn't worry about that right now. Let's just look at the molarity for a minute. The molarity is 0.100 molarity. So that means you have 0.100 moles in 1 liter of solution. Now, the chemist does not want to make 1 liter of solution. The chemist wants to make 2.5 liters of solution. So, in order to get the liter to 2.5, don't we need to multiply it 2.5 times because we're making more? So we need to multiply this liter 2.5 times in order to get 2.5 liters. So what we do on the bottom, we have to do on the top. So we're going to multiply 0.100 moles times 2.5. So that's going to give us 0.250 moles. So now we know that we need 0.25 moles of KCl for the chemist's 2.5 liter solution. But that's not what the question's asking. The question's asking how many grams. So now we need to find out how many grams in KCl are in a mole, so we can find out how many grams are in our 0.25 moles that we figured out. So for that, we go to the periodic table, and we need to find out KCl, how many moles is in KCl. So K is over here, that's 39.10, and Cl is over here, that's 35.45. You add them together and you get 74.55. So 74.55 grams is in 1 mole of KCl. Let's go back to our practice page now. So 74.55 grams of KCl is equal to 1 mole of KCl. But we only have 0.25 moles to use of KCl. So if 1 mole is 74.55, we're going to take our 0.25 moles that we have and we'll put it over 1, and then we're going to take 1 mole of KCl equals 74.55 grams. So 0.25 moles times 74.55 is 18.6375. And 1 times 1 is just 1. So we can just get rid of that 1 because we don't need it to be over 1. So this is 18.6375 grams is what is needed for 0.25 moles of KCl. And we need 0.25 moles of KCl because that's what's needed because the chemist needed to make 2.5 liters of it. And he needed to make 2.5 liters of a 0.1 molarity. So just to backtrack a little, that's how we got all these numbers. Okay, now the second problem. A laboratory procedure calls for making 500 mils of a 1.4 molarity of potassium nitrate solution. How much potassium nitrate in grams is needed? So let's look at this 1.4 molarity of potassium nitrate. So as you should know by now, a 1.4 molarity means 1.4 moles in 1 liter of water. So we know we need 1.4 moles for every 1 liter of water in a 1.4 molarity. But we're not making 1 liter of water. The laboratory procedure calls for making 500 milliliters. So 500 milliliters, if you remember my trick, 500 milliliters, if you just take the decimal and move it up 3 places, that's going to give you how many liters? So 0.5 liters. So we have 1.4 moles for every 1 liter because it's a 1.4 molarity. But we need to turn that liter into 0.5 liters. So if we need to turn that liter into 0.5 liters, can't we just divide 1 liter by 0.5 and get the divisor? Yes, we can. So 1 liter divided by 0.5 is going to be 2. So that means our divisor for 1 liter to turn it into 0.5 liters is 2. And so what we do on the bottom, we have to do on the top. So 1.4 moles divided by 2 is 0.7 moles. So we need 0.7 moles for this laboratory procedure. But that's not what it's asking. The question is asking is how much potassium nitrate in grams is needed. grams, grams, grams. So we need to convert this 0.7 moles into grams. And the only way to do that is to go to the periodic table with KNO3 and find out how many grams per mole it weighs, and then we can find out how many grams are in zero point 0.7 moles. So let's go to the periodic table. So KNO3, that means we have 1 mole of potassium, which is right here, which is 39.10 grams in a mole. And then we have 1 mole of nitrogen, which is right here, which weighs 14.01 grams. And then we have 3 oxygens. So remember, oxygen is 16, but we have 3 of them. So 16 times 3 is 48. So 3 oxygens is 48. So if we add this all up, we get 101.11. 101.11. 101.11 what? Grams. Grams and 1 mole of potassium nitrate. So let's take this 101.11 grams per mole back to our practice problem. So 101.11 grams per mole. But we don't need an entire mole, do we? We need 0.7 moles. So all we need to do is take this 101.11 grams per mole and multiply it by the 0.7 moles, which gives us 70.777 grams. So the answer to the question is the scientists need 70.777 grams of potassium nitrate to put into 0.5 liters of water to make the solution. And that's your answer.